Hi, this is Bob Pryor. Welcome to math again. Oh, in case you've forgotten what day it is, we're in the 21st century now. Okay. We're going to be discussing very briefly, actually, definitions of algebra from section 1.8. And I am starting at example 6. So I guess that probably means something. I'm not sure what. Now, I think what it means is the book is readable and the other examples are relatively self-explanatory, meaning read through the book and I think you'll get them. If you really don't understand them and the exercises that follow, then please send a message to your teacher, to other students, and try to get that understood. But I'm focusing on probably the most challenging part of the section, and not that it's all that challenging, but here we go. Definitions of algebra. What we're looking at here are the names of the operations like sum, which means addition, and difference. Product. Product means multiplication, etc., etc. We'll go through these one at a time. Excuse me. Example 6 here, we're asked to write this in algebra. And what that means is when we come across something like the words a number, we're talking usually about x. Now it could be n for number, or it could be y, or any variable really. You can use just about any letter you wish to represent a number, but typically we use x. I'm not sure why. It just, it turns out it's not a very much used number or letter in the alphabet, so we give it as much use as we possibly can here in algebra, trying to keep things balanced, So when we read these are very straightforward. These particular sentences or expressions are very straightforward. Example 8 is going to be less so. It'll be more complicated. So we need to understand the easier ones, the more straightforward ones first before we get to the next. Again, sum, here it is. That means plus. And we use a number to represented by x. So that becomes sum of a number, x, and 18. It's x plus 18. Make that blue. Okay. And that's all there is to that. Difference. Difference is a subtraction. And the way it's defined is we read it in order. So here we have a number. There's the x again. And then 3. Oh, you might also notice, let me highlight this, the word and. The word and. That's because these operations, like addition and subtraction and multiplication and division, they always happen between two numbers. So we have to say one number and another. And it might be a number like x and 3, which is exactly what we have right here. So x minus 3, because it's difference. Here's difference again. This time 17 is a number is written first. It's subtraction, and there is a number. So 17 and a number means 17 minus x, the difference. The product, multiplication, we can use that symbol. Notice that I'm using this symbol here, the dot, not as a decimal point, but as a multiplication, because we are using x for a number. I don't want to use the x multiplication symbol, because that would be too confusing. So the product means multiplication, and this one would be of a number, x, and 6. X times 6. X times 6. Quotient. Quotient means divided by. Now, we can use this division symbol here. We can actually use this division, the fraction bar, also if we wanted to. Typically, for this direct translation, we're going to use this division. But both of them actually are legitimate. Of a number, that's x, and 5, the quotient of x and 5. Or x over 5 in a fractional form. I'll put a little or right there. One way or the other is fine. Quotient, there's quotient again, divided by. This time we have 20 first, and 20 is divided by a number, x. Or 20 over x, either way. The square of a number. Now you notice that there's no word and here. In all these others, with difference we had and. With product, and. Quotient, we had one thing and another. One number and another. We don't have that with letter G or H, the square of a number. That's because they relate and apply the square, little 2, power of 2, exponent, to only one value. In this case, square of a number means x squared. Or the square root of a number means square root of x, a single number. Okay? So that's example 6. Let's move on to example 7. Here we have 5 expressions, and these expressions each have excuse me, two operations. Here we see subtraction, and we also have an exponent. We also have a variable which will be represented by the word a number. Here we have addition, and we have a square root or a radical. Here we have addition, and we have a square root also. And we have divided by, and we have a fourth power. Here we have divided by and fourth power also. Now, the example 7, I'm going to look in the book. This is found on page 8 in our text. We have discussed the main operation in section 1.6, so you might need to refer back to that. But let me write it here as a reminder. The main operation is the last one to be applied. And that means if we were actually, and I'll say here according to, that means if we were actually using the order of operations and evaluating this. The main operation is the last one to be applied. So in thinking about it, what would we do first here if we were using the order of operations? We have a square, exponent, and we have subtraction. Yeah, we do the square first, because that has a higher rank than subtraction. We have a square root here, and we have addition, which will be done first. You might think the square root, oh, yeah, you might think that, but because, oh, you said that because addition is always last. Well, that's true if there are no grouping symbols. But here we have a grouping symbol, the radical. And that means that addition will have, since it's inside the grouping symbol, the radical, the square root, it would have to be done first. And compare that with letter C. Here, the plus sign is not within grouping symbol. It's done last because it's not grouped. This grouping symbol, the radical, the square root, would actually be done first. We'd apply that first. Now, we can't apply it because we don't know the value of x. But that's, we think of this as if we could. If we could apply these operations, the square root and addition, then we would do the square root first because there's no excuse me just a minute. Hello? Hello? Oh, it's for you. Could you call back? We're in the middle of doing a video right now. Yeah. Well, no, I really can't pass you on. I think that's rather impossible. So, oh, you wanted to help. Do you mind? If we, okay, well, go ahead. I misunderstood what you were asking. Yeah, let's go ahead and do number 1. What is the main operation? That's right, subtraction. I'll write that down here, subtraction. Okay. And the main operation next for letter B? The square root? Remember, it's the last one done, the last one to be applied. And as I was telling them, maybe before you called, maybe you didn't even know, that we do what's inside the parentheses, or the grouping symbol first. So actually addition would be done first, and the square root would be... Is that what you said? The square root's the main operation? The Man, I guess I'm not paying attention. I'm sorry. Radical is the main operation. Yeah, I'll right here, square root. Abbreviate that. Okay, yeah, I misunderstood what you said. Okay. And you ought to be teaching this thing, man. All right. All right. Go ahead. Next one is addition. Addition is correct because we would do the square root first and then the addition. Okay, good. And what about here? We have division and power. Which will be done first? Exponent has a higher rank. That's true in general, but what? Division is done first because, that's right, it's in the grouping symbol. Excellent. Yeah, we do division first, and that's not the main operation. It's the last one to be done. It's the power. So you're right. I think it's the power of 4, or the fourth power. I could write it that way. Fourth power. Oh, and did you notice this one looks very much the same? Man, you're good. That's right. This time division would be the main operation. Because there are no parentheses, there are no grouping symbols. We would do the power first, exponent, and then division. All right, well, thank you very much. Yes. Yes. I love you too. Now, in English, subtraction is written as difference. So this subtraction is going to be the difference of one thing. Remember the word and another. What? X squared and 3. Good. This will be the square root of. That's the main operation. Notice how, again, the main operation is what starts the sentence in English. So we'll start with the square root of. Let me do a different color here. The square root of what? X and 2. Oh, no. Okay, wait. Square root of x plus 2. Square root of x plus 2. That's what we're taking. It's the square root of what? X plus 2. And this next one here will be, since it's addition, that means the sum of square root of x and 2. The fourth power of, okay, the fourth power of 20 divided by x. The fourth power of 20 divided by x. And lastly, division. What's the word for division? Quotient. Whoops, so the quotient of 20 and x to the fourth. I almost got a little confused here with the square root and the fourth power, because the square root doesn't have an and with it. And I started writing an and I thought, that's not right. Difference and. Sum and. Not fourth power, just fourth power of that. Quotient and. Okay? So notice that there are certain things that will always have the and, the basic operation and, you know, these product. If I would have had product here, multiplication, and product of something and something else. Okay? One thing about this, and we're going to look at this in example 8, is that sometimes, once we say the difference of something and something, sometimes that something can itself be expressed in English. Like, we could have said the difference of the square of x and 3. Or the square root of, here, this is a sum, right? The square root of, what? The sum of x and 2. Or the sum of the square root of x and 2, etc., etc. So this is what we've done for example 7. Example 8 is going to take it to the next level. And we're actually going to write out everything, because even this one here, this right here is by itself a quotient of 20 and x. So we're going to look at interpreting, I'll admit, some challenging problems here, but let's find out what we get here. Example 8. This set of exercises is more challenging. What we're asked to do is to translate each of these expressions into algebra. And we've got to recognize here that this very first word, sum, difference, product, here square root, here's sum again, fourth power, quotient, these are the main operation. And what that means, this is challenging stuff, I'll admit, but hang in there with me. What that means is this: the sum of the product two, we're going to have addition here. One thing plus another. The difference of something, a minus. Product of times, that's what product is. Square root of something. Square root, main operation. The sum of two things. The fourth power of something. That's an exponent there. The quotient of something. And for most of these, we have something on each side. Something plus something else, right? For addition, we got one thing plus another. Same thing here. I'll put this down here. Whoops. I'll put these green lines down here, and then erase them just a little bit. We have two sides to a product, right? And for addition again. For division as well. Two sides. So what we've got to do is read carefully. In fact, I'm going to start right here at letter B. The difference of 2 and something else. The difference of 2 and something else. So this of 2 and, the difference of 2 and, that's where the minus sign comes into play, something else. Well, what's that something else? That something else happens to be the sum of a number and 5. Well, that's kind of lyrical almost. The sum of a number and 5. The sum of a number, sum, that's plus x plus 5. But to make this fully understood that the main operation is subtraction here, I've got to do something to make see, left to right. I've got to do something to make sure that this is the operation that comes first. And the only thing that I can do there to make sure that comes first is to put parentheses around this. Okay? The difference of 2 and the sum of a number and 5. Difference of 2 and the sum of a number and 5. So I actually did letter B first. I hope you don't mind. Okay. So, let's see. How's this going to work? The sum of something and something else. Well, this time we don't have a number right away. The sum of the product of 2. Oh, product. But product itself has two parts to it, doesn't it? Look at this. We've got little things going on inside here. The product of 2 and a number. In fact, this is going to test your thinking skills. The sum of one side of that plus sign is the product of 2 and a number. and the other side is just 5. So let me write in the 5, and the other side is the product of 2 and a number. 2 times x, or just 2x. 2x plus 5. I'll erase the green lines underneath. In fact, with that answer, I'm going to put a box around it. Here's one S for letter A, and here's for letter B. We've already done those two. Okay. These require some thinking. I hope they don't strain your brain too much. The product of, okay, now remember, we're going to have one thing times another. So let's see, the product of 3 and the square of a number. The product of 3 and the square of a number. The product of 3 and the square of a number. That's what's being said here. The product of 3 and the square of a number. This is the main operation. Does that still hold true the way I've written it? We would do the exponent first and then the multiplication, right? Good. Now, we might want to tighten that up. Even though that's accurate, I might want to write it as just 3x squared. That's the product 3 times. Let me show the little times sign there. So there's the answer. Or, if, here's a bigger version of the answer. 3 times x squared, 3x squared. Okay? The product of 3 and the square of a number. Okay. Now remember, this time the square root is the main operation. So square root's a grouping symbol, and since it's the main operation, that means that the first operation must be done inside the grouping symbol. So we're going to put the rest of this phrase, and there's no and directly for square root. There's just the sum of a number and 2. The sum of a number and 2, x plus 2, fits inside the square root. So there's the answer for that one. Okay. Let's see, the sum of the square root of a number and 2. The sum, addition again. We've got 2 sides. What's one side? What do we read right away? The square root of a number. And this and, since it's the only and in this, must apply to the word sum right here. The sum of the square root of a number and 2. So one side is the square root of a number, and the other side is 2. Let's think about that. Is that what it says? The sum of square root of x and 2. The sum of the square root of a number and 2. We're adding square root of x and 2. Okay. That was done. That was tricky, I know. Now the fourth power, before we go any much with this, I've got the fourth power written up here, kind of like an exponent, of the quotient of 20 and a number. Now, the quotient of 20 and a number, that's another operation, isn't it? Quotient of. And in order for us to get this in place, we've got this operation, and we've got to make sure that the fourth power is the main operation. And usually exponents have higher rank than quotient would, which is division. So the only way to make the exponent be the main operation and have a lower rank is if this quotient is in parentheses. Yeah. Quotient is in parentheses. So what goes inside those parentheses? The quotient of 20 and a number. 20 divided by x, quantity we say, to the fourth power. Or the fourth power of 20 divided by x. Or the fourth power of the quotient of 20 and x, and a number. Now this one's a little bit different. It's written differently. The quotient of 20 and. So we've got a quotient of, which means, again, quotient's got to be, got two sides to it, of what and what. Well, notice that the and is right here, right away. Quotient of 20 and what? The difference of a number and 8. So on the other side, we've got this other piece to it, the difference of a number and 8. Now, difference has a lower rank than division. And yet, as I said, here's the main operation. So quotient has to be the main operation. That's the last thing to be done. That means that this minus sign has to have a higher rank. But the only way subtraction can have a higher rank is if what? Yeah, what would bring subtraction to the top of the rank in order of operations? Exactly, parentheses, grouping symbols, right? So yeah, we're going to have some kind of parentheses here. Parentheses around what? The difference of a number, x, and 8. X, the difference of x and 8. Let me erase these underlines here. Wow. Oh, I forgot to put a box around this other one here. The letter F. Yes, I agree. Tough stuff. Okay, well, there you have it. That's example 8 in section 1.8. I make no apologies. I want to say I'm sorry, I had to teach this to you, but this is tough stuff. Just think and one step at a time. Okay? All right, well, I'll see you in section 1.9.